Let's look at this question here. The set of values of x for which this equation given holds true. Alright, they're asking for the general solution of this given equation. What is the equation? Tan 3x minus tan 2x by 1 plus tan 3x into tan 2x equal to 1. Look at the LHS here. The LHS says tan A minus tan B by 1 plus tan A into tan B equal to 1. Alright, does the LHS look familiar? Tan A minus tan B by 1 plus tan A tan B. Alright, that is nothing but tan of A minus B, where A is 3x and B is 2x. Alright, so let's see what we get from here. We have tan 3x minus tan 2x by 1 plus tan 3x tan 2x equal to tan of 3x minus 2x, tan of A minus B. Alright, and that comes out to nothing but tan x. Alright, so this is our LHS here, new LHS, which is tan x. What's our RHS? Equal to 1. Alright, RHS is 1, tan x is the LHS. Now, what are the values of x that satisfy this? So remember guys, I can write 1 as tan pi by 4. Alright, so now I have tan x equal to tan pi by 4. Whenever I have tan x equal to tan alpha, how can you find the general value of x? X will be n pi plus alpha. Alright, so let's apply that here. So x becomes, in our case, n pi plus pi by 4. Alright, will that be the right answer? Not yet. Guys, don't directly go check it off. It will be there in the options. This one, x equal to n pi plus pi by 4. You have to cross check if it can be validated with the first equation. Okay, the second equation is just a version of the first equation we got. Alright, we need to validate it with the first equation. In that you can see there's a 3x and a 2x. Alright, let's apply this to 2x. What is 2x? 2x becomes 2n pi plus pi by 2. Now, in our first equation, in the question, it's given that tan 2x. Alright, there is a tan 2x there. Now, what is tan 2x here? Tan 2x will be tan of 2n pi plus pi by 2. Okay, so for an example, put n equal to 0. What do you have? Tan pi by 2. Is tan pi by 2 defined? No. Alright, so because of that, tan 2x will not be defined. Okay, now can x equal to n pi plus pi by 4 be applicable to our question here? That is why we are validating. Alright, once we find out that these values of x equal to n pi plus pi by 4 does not satisfy tan 3x minus tan 2x by 1 plus tan 3x into tan 2x equal to 1, then what do you get? You can say that this is not a valid solution. X equal to n pi plus pi by 4 is not valid here. So what will our answer be? What values of x satisfy this? Nothing. There are no values of x that satisfies this equation. So what will our answer be? Our answer will be option D. Got this? D will be 5. Null set. Alright? Take a look at this question here. The general solution of the equation 1 plus sin x into sin square x by 2 equal to 0 is, where n is any integer. They are asking for the general solution of this given equation. Alright, so we have this equation given to us. We need to find the general solution. For that, you notice that there's an x and an x by 2 angle on the LHS. Alright, our LHS has an x and an x by 2. Sin square x by 2 and the sin x. Alright, so first what I'll do is I'll simply multiply the whole equation by 2. So then I get 2 plus 2 into, I'll write sin square x by 2 first. Alright, and then there'll be a sin x. Why did I do that? Because 2 sin square x by 2 looks familiar to me. What is 2 sin square x by 2? It is nothing but 1 minus cos x. So here, 2 sin square theta by 2 is 1 minus cos theta. So that same thing I'll apply it in the next step. So I get 2 plus 1 minus cos theta into sin x equal to 0. Alright, I'll rewrite that as 2 plus sin x minus sin x into cos x. Alright, that was cos x there. So you get minus cos x equal to 0. I'll simply multiply this given equation again by 2. Why would I do that? We'll find out now. So I multiply the whole thing by 2 to get 2 sin x cos x. What is 2 sin x cos x? That is nothing but sin 2x. Alright, so 2 sin theta cos theta is sin 2 theta. Let's use that here to get 4 plus 2 sin x. I'll just take this term to the RHS and then it becomes sin 2x. Alright, so now again look at our LHS and our RHS. What do we have here? In the LHS, I have 2 sin x. Okay, 4 plus 2 sin x. But let's look at the sin x part. The sin x part, as you know, the sin x part is between minus 1 and 1. Okay, sin of any value of x will be between minus 1 and 1. What about 2 sin x? 2 sin x will be between minus 2 and 2. Alright, so now we can say that 2 sin x is between minus 2 and 2. Now if I add 4 to it, what will happen? The lower limit and the upper limit will get bumped up 4 units. Alright, so then I can say from here, my LHS, okay, it was already between minus 2 and 2. I'll be adding 4 to each of these parts. Okay, so from this I can say that my LHS is between minus 2 plus 4, which is plus 2, and then 2 plus 4, which is 6. Alright, what about the RHS? What about the RHS here? RHS is sin 2x. Okay, sin 2x, sin of anything, any value will be between minus 1 and 1. So I can say sin 2x here is between minus 1 and 1. Alright, so what does that imply? What does that imply in this context? You have your LHS. Okay, let's plot a random number line here. Plot these values out. 2 and 6. Alright, our LHS is between 2 and 6, which means somewhere in this region is where our LHS will lie. What about our RHS? Our RHS is between minus 1 and 1. Okay, so between minus 1 and 1, okay, is our RHS. What can you say here? You can say that the LHS can never be equal to the RHS, whatever value of x you put. Because at the same time, both should hold the same value for them to be equal. Now, if it's given to me that my RHS is between minus 1 and 1 and that my LHS is between 2 and 6, they can never be equal at the same time. Alright, so using this logic, we can say that, we can conclude that the solution will be the null set. It will not exist. There will not be any solution for this equation given to us. Alright, so that's why we get our answer as option D, no solution. Got that? Alright. We are looking for the value of x satisfying this given inequation. Alright, we are looking for the general solution of that. Alright, so let's get to solving this. We have our inequation here, sin power 4x by 3 plus cos power 4x by 3 greater than half. Alright, so I see sin power 4 theta plus cos power 4 theta. How can I write that differently? Sin power 4 theta plus cos power 4 theta can be written as sin square theta plus cos square theta the whole square. That's where sin power 4 theta and cos power 4 theta comes from. But there's an extra term inside which we have to cancel out. So that's why we subtract 2 sin square theta cos square theta from it. Alright, so in our context, okay, look at the first part here. The first part says 1. Why? It's sin square theta plus cos square theta. So I'll write this as 1 minus 2 sin square x by 3 cos square x by 3 greater than half. I'll shuffle the whole thing and rewrite it as 2 sin square x by 3 cos square x by 3. This went to the RHS. Okay, so the sign will flip here and you get 1 minus 1 by 2, which is 1 by 2 here. Now what we can do is, I'll take the 2 from the denominator of the RHS to the numerator of the LHS. Okay, so the denominator becomes, the RHS becomes 1 and the numerator of the LHS becomes 4 sin square x by 3 cos square x by 3. Now, what I want you to notice is sine theta cos theta into 2 is nothing but sine of 2 theta. And we have the square of that on the LHS here. Alright, so this can be written as sine square 2 theta, which is 2x by 3, will be less than 1. And we already know that sine square of anything will always be less than or equal to 1. Okay, so here we could have said that x is any real number, but there's an exception. Okay, but there's an exception. What is the exception? The case where sine square 2x by 3 is equal to 1. Okay, this is the case we should be careful of. Alright, now how do we solve this sine square 2x by 3 equal to 1? 1 I will write it as sine square pi by 2. Because right now I have it in this form, sine square x equal to sine square alpha. Then what do? If you get sine square x equal to sine square alpha, you can say that x is nothing but n pi plus or minus alpha. Alright, so in this context, you get 2x by 3 equal to n pi plus or minus pi by 2. Or in other words, x is equal to 3n pi by 2 plus or minus 3 pi by 4. Okay, so I got x equal to 3n pi by 2 plus or minus 3 pi by 4. Alright, but then that was the case I was supposed to remove from R. Alright, if I take these cases, this is not my answer, this is the exception case. Okay, so I removed this much from R to get my final solution set. So my solution set will be R equal to, my solution set will be R minus x, where x is 3n pi by 2 plus or minus 3 pi by 4. Alright, so let's look at our options and we'll see that it's nothing but option C. Got that? Take a look at this question. If this equation has no value of x for any value of y, then A belongs to. Basically, they've given that this equation sin x plus cos x equal to y square minus y plus a will have no solution. Alright, if it has no solution, then where does a lie? Okay, so it's given that this equation has no solution. Where will a lie for such a case? Now, look at this here. Sin x plus cos x, I will divide this by root 2 and multiply by root 2. Alright, so I'll divide by root 2 and multiply by root 2. And this first 1 by root 2, I will call it cos pi by 4. And the second 1 by root 2, I'll call it sin pi by 4. Okay, now I have sin x cos pi by 4 plus cos x sin pi by 4, which is nothing but sin a cos b plus cos a sin b, which is again nothing but sin a plus b. Alright, so now I have root 2 into sin a, which is x, plus b, which is pi by 4. Look at the RHS now. Y square minus y plus a, y square minus y plus a. Now, y square and y term is there. If I add a plus 1 by 4, what happens? This becomes a perfect square. So outside the bracket, I will subtract minus 1 by 4. So now I can rewrite the RHS this way. This will become y minus half the whole square plus a minus 1 by 4. Okay, now again, I'll rewrite the whole thing as a minus 1 by 4 is equal to root 2 into sin x plus pi by 4 minus y minus half the whole square. Alright, now look at the RHS closely. There are two parts to the RHS. There's a sin term and a y term. Okay, so let's look at the sin term first. Sin of anything lies between minus 1 and 1. Agreed? When you multiply that sign by root 2, that value, the entire value, root 2 into sin of x plus pi by 4 will lie between minus root 2 and plus root 2. Okay, next, let's look at y minus half the whole square. This is nothing but a simple whole squared. So that will be from 0 till infinity. Okay, But that's a value we are subtracting from the first part. Okay, so now let's look at this closely. We can see that the whole thing, okay, the maximum value it can take is when the first part takes the value root 2 and the second part takes the value 0. You're subtracting both. Alright, so you can see that the maximum value this whole thing can take is root 2. What about the minimum value? You're subtracting a whole square. The whole square can take an infinitely large value. Okay, when you subtract that, that becomes the minimum value. Okay, so it goes till minus infinity. Okay, so here you can say that a minus 4, okay, a minus 1 by 4, alright, will be less than or equal to root 2. So that is when this has a solution. The given equation has a solution. But it's given in the question that the given equation does not have a solution. Alright, so this equation does not have a solution. What does it mean? If it does not have a solution, then it just means one thing. For no solution to exist, okay, for no solution to occur, a minus 1 by 4 has to be greater than root 2. As simple as that. Alright, for no solution to exist, a minus 1 by 4 should be greater than root 2. In other words, a should be greater than root 2 plus 1 by 4 or 4 root 2 plus 1 by 4. Okay, so what can you say about a? A will be between 4 root 2 plus 1 by 4 till infinity. Got this? Okay, so for this equation to not have a solution, you need a between 4 root 2 plus 1 by 4 till infinity. Alright, so here we are looking at nothing but option D here. Alright, so that is our answer. Got that? We are looking for the set of all x in minus pi to pi satisfying this given inequation. Alright, let's get to solving this. We have mod of 4 cos x minus 1 less than root 5. So in other words, if I remove the mod, I can write it as 4 cos x minus 1 between root 5 and minus root 5. Alright, once we get that this is between these values, I can say that cos x, alright, cos x will be between root 5 plus 1 by 4 and minus root 5 plus 1 by 4. Alright, so from here, what can you say? That 1 minus root 5 by 4 is cos 3 pi by 5 and 1 plus root 5 by 4 is cos pi by 5. Alright, where did these values even come from? Let's find that out as well. Alright, so you should remember one thing, that sine 18 is root 5 minus 1 by 4. Alright, sine 18, also known as pi by 10, sine of pi by 10 is root 5 minus 1 by 4. Now, in terms of cos, how would I write it? Cos of pi by 2 minus pi by 10. Okay, which will be 5 pi by 10 minus pi by 10, which is 4 pi by 10, also known as cos of 2 pi by 5. Alright, so then you get cos 2 pi by 5 also equal to root 5 minus 1 by 4. Why is that useful here? Because we know that cos of pi minus theta is minus cos theta. Okay, cos of pi minus theta is minus cos theta. Replace theta with what? With 2 pi by 5. Okay, with 2 pi by 5. We just got the value here. Alright, so replace theta with 2 pi by 5. Then what do you get? What is cos of pi minus 2 pi by 5? That becomes cos of 3 pi by 5 equal to minus cos 2 pi by 5, which is minus of root 5 minus 1 by 4. Why did I do this? Because I noticed the first term here in this inequation. Okay, the first term, 1 minus root 5 by 4 is the negative of sine 18 or sine pi by 10. Okay, so 1 minus root 5 by 4 is this. Alright, we can say from this that root 5 minus 1 by 4, the negative of that is cos 3 pi by 5. That's how I got my first part here. Okay, what about the second part? It says cos of pi by 5. Okay, now cos of pi by 5, how do I find that out? That's nothing but cos of 2 into pi by 10. Okay, cos of 2 theta. Can I write cos 2 theta in terms of sin theta? Okay, because I see this pi by 10 here. That's the idea. So I can write cos 2 theta as 1 minus 2 sin square theta. In this case, it's pi by 10. Alright, so then this becomes 1 minus 2 into sin square pi by 10. Root 5 minus 1 by 4 the whole square. So, root 5 minus 1 by 4 the whole square becomes 16 in the denominator, and root 5 minus 1 the whole square becomes root 5 square, which is 5, plus 1 minus 2 root 5. Okay, so then this comes out to 1 minus, what is the numerator here? 6 into 2, which is 12, minus 2 into 2, which is 4 root 5, divided by 16. Okay, so now I get, what do I get here? 4 by 16, alright, which is 1 by 4 minus root 5 by 16. Alright, sorry, plus, minus and minus become plus here. So I get root 5 plus 1 by 4, and that is how I arrive at the second conclusion here. Okay, that cos of pi by 5 is 1 plus root 5 by 4. You must have also noticed I wrote it as cos plus or minus root 3 by 5 and cos plus or minus pi by 5. Cos theta and cos minus theta are the same thing. That's the logic here. Alright, let's move ahead. We have this in equation here and we got these two things just right now. Okay, let's just draw the graph of cos x and find what values of x give cos x between these two values. Okay, so I draw the graph of cos x and then what do? I find out what is root 5. Root 5 is roughly 2.2 something. Okay, so 1 plus 2.2 by 4 is 3.2 by 4, roughly, okay, it is 0.8. Below part, 1 minus 2.2 by 4 is minus 1.2 by 4, so roughly minus 0.3. Okay, so these are the two lines I'll be drawing between which I'll be looking for the values of x required. Okay, so let's draw the two values. Y equal to 0.8. Okay, so that gives me my first set of values here. Y equal to minus 0.3. Minus 0.3 should be somewhere here. Okay, so here I can say that this value 0.8 is nothing but plus or minus pi by 5. Okay, so this is pi by 5 here, minus pi by 5 here, and this is pi by 5 here. Okay, and then the next set of values is at 3 pi by 5, as you can see. So this becomes minus 3 pi by 5, and on the right side you get plus 3 pi by 5. And what are we interested? In the region between them. Okay, not these 2 points, not the 2 points themselves, because it's less than. Okay, if it was less than equal to, I would have included them. Right, so between these 2 points, I just mark it out like this, and that's the region where I get cos x between these two values. Okay, so now what can you say about the values of x? The first part says that x is between minus 3 pi by 5 and minus pi by 5. I will not be including either endpoints. Okay, then or where can x lie? It can be between pi by 5, this is the second region here, pi by 5 or 3 pi by 5. Alright, so from this I can say that these two parts, we'll take the union of them to find the correct value of x. Alright, all the values of x will be in the union of these two parts here. Okay, let's look at our options now. We're looking at nothing but option C here. Got that?